Minecraft Steve is capable of some pretty crazy feats. He's got a 44-inch vertical jump, can survive a fall from over 20 meters, and tunnel through the earth at speeds 1,000 times that of modern mining equipment. Some people have even estimated him to be strong enough to hold multiple Eiffel Towers or even the universe. But we don't care just how strong he is, but rather, how dangerous is he? In this video, we're going to bullshit some math for 3 different scenarios in which Steve attempts to wipe out all life on Earth. Direct impact, mass flooding, and in case either of those don't work out, some sort of cosmic conundrum. Before we turn Steve into an asteroid, we actually do need to find out how strong he is, by comparing him to one of the most famous strongmen in the world, Eddie Hall. He is remarkably known for setting a world record deadlift of 500 kilograms, or for you Americans, about 9,000 hot dogs. For Steve, however, that's about 2 gold nuggets. I know that doesn't sound right, but bear with me. Gold has a density of 19.3 grams per cubic centimeter. I know this because I'm a chemistry and IBM double major, and not because Google AI told us. We also know that, like Minecraft, these units are in metric, meaning one block in Minecraft is literally just 1 cubic meter. So we can scale grams per cubic centimeter into kilograms per block. That math leaves us with 1 gold block weighing in at about 20,000 kilograms. So if 1 gold block is 9 ingots, then each ingot is about 2,000 kilos, making each nugget about 240 kilos. So only 2 nuggets weigh in just shy of Eddie Hall's 2016 world record breaking deadlift. As you can see, we are getting extremely hypothetical and mathematical, and we'd like to make a few important disclaimers. Number 1, we don't have the capacity to hire a Harvard-educated astrophysicist, so this might not be the most accurate thing ever. Number 2 is that we're going to be using the metric system instead of bald eagle heart disease per football field. So to make it simple, anytime I say kilogram, that's about double a pound. But is gold the heaviest item in the game? Some say that netherite is more dense because it's 4 gold per ingot, but notch apples used to be crafted with 8 gold blocks, making 1 notch apple twice as dense as a netherite block. But why stop there? What if we completely filled our inventory with shulker boxes completely filled with stacks of notch apples? If we were to take the mass of 1 gold block, being 19,000 kilograms, multiplied by 8 for every apple, by 64 for every stack, by 27 for every shulker box slot, and then again by 37 for every shulker box in your inventory, you get a lot. That's right. That's approximately way more than Eddie Hall could lift. Also known as 10 billion kilograms, which is 20 million times heavier than Eddie Hall's PR. So clearly he needs to hit the gym. We know that Steve can carry a lot of weight, but what are the real world implications of this? Let's talk about a good old-fashioned myth. If you were to drop a penny from the Empire State Building and it landed on someone's head, would it kill them? Air Resistance and the Mythbusters say no. So here's a better question. What if you dropped the Empire State Building on someone's head from the height of a penny? Steve, with a full inventory of notch apple shulker boxes, would weigh 30 times more than the Empire State Building, or about 20 Burj Khalifas for you non-Americans. Needless to say, if Steve were to fall on someone, it would kill them, or at the very least, really, really hurt. Let's ramp up from the height of a penny. What if Steve landed on you from the 10th story of an apartment building? The 10th story of a commercial building? What if he fell from the outermost layer of the atmosphere? Would he kill you? Yes. Would he destroy an entire building? Yes. Would he level an entire city? One could hope Baltimore. Does he have enough momentum and enough mass to have an impact comparable to that of the Chicxulub Impactor, the asteroid that wiped out the non-avian dinosaurs over 66 years ago? Let's find out. Starting off by finding who we are competing against. The Chicxulub Impactor asteroid, better known as everyone's least favorite space rock for taking away the T-Rex, weighed in around 1 quadrillion kilograms. For you Americans, that's around 6 Americans. Not only was it extremely heavy, but scientists estimated its impact velocity at a staggering 20 kilometers per second. That's the length of 180 football fields a second for you Americans, or 180 football fields for you non-Americans. In order to compare Steve to the asteroid, we're going to have to look at its momentum, which will be measured by its mass times its speed. The asteroid is very easy to calculate. It's just 20 times 1 quadrillion, making its impact momentum 20 quadrillion. If you took the free fall terminal velocity in Minecraft of 78.4 meters a second and turned that into kilometers per second, then multiplied that by Steve's mass of 10 billion, you get 800 million, which is not even close to the asteroid. But what about a city killer asteroid? Could Steve actually wipe out Baltimore? These asteroids luckily aren't nearly as large, coming in at a total of 200 million kilograms, and if we assume they come in around the same speed, that's still 5 times larger than Steve's impact, so not quite. Moving on to scenario 2. Oh, hold on. Did you really think I'd let Baltimore off the hook that easily? No shot! We need to find a way to either increase Steve's mass or increase his speed. We're already using the theoretical densest possible item in the game, so we're gonna have to figure out a way of moving faster. Minecarts are only 8 blocks a second, horses around 14, ice boats at 40, and elytras in the 70s. So then, what's faster? Using ender pearls, we can actually travel way faster. If you watch an ender pearl teleportation in slow motion, you can clearly see that Steve is traveling through space from point A to point B in a fraction of a second. So by measuring how far a player can teleport and how long it takes to travel, we can calculate a new impact momentum. A Minecraft world is 60 million meters wide, which makes it about 50% wider than the Earth, and much like the Earth, Minecraft is flat. So if we were to set up an ender pearl stasis chamber at the very corner and travel to the opposite corner, some weird Greek dude who liked triangles would tell us we actually traveled diagonally 85 million meters. It takes a pearl only 1 in-game tick to teleport, and with 20 ticks a second, you're traveling 20 times faster than 85 million blocks in a single second. That puts us at a staggering 1.7 million kilometers per second. That is the equivalent of running around the Earth 43 times in 1 second. Or going 5 times faster than light, which isn't actually possible, but clearly Steve doesn't abide by physics, so moving on. With the newly calculated speed and original mass, we have a new impact momentum of 16 quadrillion, which is unbelievably close to the asteroid's impact of 20 quadrillion. So if it was enough to wipe out the dinosaurs, it would be more than sufficient for Baltimore and possibly all life on the planet. So we know that Steve could most likely destroy the Earth through sheer force, but what about a more realistic approach? What about an approach that humans have already been doing for centuries? Global warming. A process that has been rapidly increasing as a result of abundant fossil fuel usage and overpopulation. The more greenhouse gases in the atmosphere, the more heat it traps, leading to the warming of Earth's climate. Do you ever wonder how much you contribute to climate change? Based on the demographics of our typical viewers, you may be producing 10 to 15,000 kilograms of CO2 every year, whereas Steve produces that much from just 4 blocks of coal. That means that a stack of coal blocks is the equivalent of flying a Boeing 767 from New York City to Los Angeles. What if we did the same thing as before and filled up every slot of our inventory with shulker boxes completely filled with coal? How much CO2 would that produce? How does 10 octovigintillion kilograms sound? Probably wrong, because I made that number up, and it's actually only 178 million. Which, to be fair, is still 500 times more CO2 than Taylor Swift produced flying around from the Eras Tour. But it doesn't really matter how much coal Steve can hold at once, but rather how much fuel he is burning total. So why don't we first figure out how Steve is going to use coal to kill you? The majority of Earth's surface is covered by water. If you paid attention at all in school, you've probably heard the threat of global warming and, consequently, the melting of land ice causing a rise in sea level. Even if Steve were to perpetuate this cycle to the point of all ice melting, it wouldn't actually kill everyone. That's because there's only enough ice to raise the sea level by about 70 meters, and only about a third of the global population lives within this range. However, an argument could be made that wiping out this much land, infrastructure, and 2 billion people would at least affect the trout population. Well, that and seriously impacting the remaining habitable land, along with causing anarchy and the fall of society. So, if Steve can't cause biblical-level floods, he can at least destroy most of humanity. So what quantifiable threshold does Steve need to surpass to achieve this? We are going to be measuring it based on the atmospheric constant of CO2 in parts per million. As of the day this video is released, the atmosphere is around 427 ppm of CO2. To put that in perspective, in 1750, it was around 280, and has been rapidly increasing since the Industrial Revolution. Even without Steve, this possesses a very serious and concerning threat. The IPCC has released public graphs showing estimated predictions of the future depending on our response to climate change. These various predictions on shared socioeconomic pathways, or SSPs, explore different possibilities from very high levels of emissions to very low levels of emissions. SSP-1 would be the best case scenario, in which we take a drastic approach to obtain sustainability. SSP-5 shows a scary future, in which we continue ramping up consumption without serious attempts at mitigation. Of course, Steve views this as a starting point. So how can Steve help move this process along? Enter SSP-Steve. This projection shows a world tormented by a raging, malicious lunatic fueled by malintent and coal blocks, whose sole goal is to raise the atmospheric composition of CO2 to a catastrophic level, subsequently destabilizing civilization. So in case that wasn't clear, we need to calculate how many coal blocks will be required to produce enough CO2 to eventually flood the coastal regions, with the end goal of the most deaths possible, of course. Scientific articles were read thoroughly and making sure they're all reputable sources that had been peer-reviewed, and after about 30 seconds of Google and none of that first stuff, we found that the CO2 threshold is around 600 ppm. After some quick calculations, every 7.8 billion metric tons of carbon dioxide corresponds to an increase by about 1 ppm. So that means that Steve needs to raise the CO2 concentration by 170 ppm, or 1.3 quadrillion kilograms of CO2. With one furnace holding a stack of coal producing 178,000 kilograms of CO2, we would need to run 7.4 billion furnaces in order to produce enough CO2 to raise global temperatures enough to flood the world. But chances are, Steve doesn't want to have to place down billions of furnaces and run them all at once, so we need a system that allows us to use less furnaces, but over a longer period of time. Assuming we plan on emitting all of the CO2 within the span of only 1 year, we have to learn how much coal a furnace can burn in that time. One coal block burns 80 items, each taking 10 seconds, coming out to 13.3 minutes per block and 853 minutes per stack. That means if we divide the number of minutes in a year by 853, we get 616 stacks. That requires about a 10.5 chest/hopper chain. So instead of 7.4 billion furnaces, we only need 188,000, which is much more manageable. To visualize what this would look like, imagine if every block in a 57-meter wide cube was a furnace. Then if we spent way too long building this, it would probably look a little something like this. Remember, every single block you see represents a full chest worth of coal blocks. So if we were to AFK for a full year and come back, Steve would have emitted enough CO2 into the atmosphere to fully melt all the ice in the world and flood every major coastal city. For our third and final apocalypse, Steve is going to open a black hole. For those that don't know what a black hole is, try and think back on where your education failed you. It's basically a supermassive and infinitely dense object in space where the gravity is so intense it warps space-time to a point not even light can escape. So how would Steve form this? You see, stars are known for having lots of gas. This gas is being forced together to fuse into new elements until they run out of fuel and eventually die. For small stars, like our sun, it'll collapse and then expand, swallowing the inner planets, including our Earth. But don't freak out yet because scientists say that shouldn't happen for at least a few years. However, an extremely massive star will supernova, oftentimes leaving behind a black hole. Lucky for Steve, not all black holes are formed from collapsing stars. So instead, he's going to try another approach. What if he were to force a bunch of mass all in the same place, so much in fact that it has the same mass as Sagittarius A, the supermassive black hole at the center of our galaxy? And realistically, if that's too much for Steve to handle, his safety black hole is the Unicorn, which is only about 3 or 4 times as massive as our sun, and happens to be the smallest black hole that we currently know of. Let's start with how Steve would do this. Theoretically, assuming that items on the ground had quantifiable weight and didn't despawn, how many items would be needed in a single pixel worth of space to be comparable to the mass of the Unicorn? Would he need to mine all the gold in the Minecraft world? Would he just need to mine the entire world? Again, I honestly have no clue. There's a lot of moving parts here. But we can start with this. We know how big a Minecraft world is, and we know what most of the stuff is in it. So all we have to do is determine the average distribution of blocks in the overworld and determine its total weight. We are going to go based off of randomly selected chunks. We originally planned on sampling approximately 36 chunks in a grid, all about 1,000 blocks apart to ensure a random variety of the world. However, we stopped at only 3 chunks, but we'll get to that in a second. We start off by using commands to make a glass dome around a chunk, and then use the /fill command utilizing the destroy function to drop all the items. Everything was then counted and put into a spreadsheet to tally the results. After only 3 chunks though, we were very eager to test our hypothesis and get to work on the math. The chunks were averaged and then multiplied by their densities to find the total average mass per Minecraft chunk. We then multiplied that by the total number of chunks in the world and discovered this. We weren't even close. We needed a number with 30 zeros, and we only had 20. That means we're over 1 trillion times off. In other words, Steve would have to mine 1 trillion Minecraft worlds in order to make this work. With this bad news, we went back to the drawing board. How do we make the world weigh more? Our first thought was to make an amplified world, but it was barely an improvement. So instead, we tried modifying a super flat world. We get the bottom block as bedrock so that Steve wouldn't fall into the void or lose items, and then replaced every single possible block in the world from -63 to +320 with solid gold. Having a density 7 times that of stone, and with literally 0 air blocks per chunk, we were hoping it would yield some pretty strong results. To find the volume, we multiplied length, width, and height, and multiplied all of that by the weight per 1 gold block. Finally, after all this trial and error and hours of brainstorming, we got a mass not quite the size of Sagittarius A, but rather our moon. So, we didn't improve much. We were only at 22 zeros, and we're hundreds of millions of times off. Even if Steve were to sit at a cobblestone generator, it would still take him multiple quintillion years to reach the mass of the unicorn. Although Steve is immortal, we don't want to AFK for that long, so we have one final idea that would guarantee ultimate destruction. We're going back to the beginning. Earlier we stated that Steve would be able to hit the Earth almost as hard as an asteroid by traveling at a whopping 1.7 million kilometers a second. This was multiple times faster than the speed of light, and apparently that's not okay with physicists. This stems from Einstein's theory of relativity, which you may associate with the equation of E equals mc squared. This is an equation so famous that everyone knows it, just maybe not what it means. Energy is equal to mass times the speed of light squared. Meaning, energy and mass cannot be created nor destroyed, but rather traded off. A general principle of Einstein's theory of relativity is that mass shouldn't be able to travel at the speed of light. This is because as speed increases, the mass is continuously increasing and increasing, so much to the point that if it were to reach the speed of light, it would have an infinite mass. Not only that, but time itself will begin to slow down and space contracts. The increase in mass and change in speed is only apparent to an observer, meaning that from Steve's point of view, his speed and weight is unaffected. But to that of the Earth, by landing a single pearl, Steve rips all of space and time apart, far surpassing anything thought possible by astrophysicists. With everything once known and everything that ever would have been gone, the only remnants of a cold and desolate universe is Steve. If you don't subscribe, Steve's gonna save Baltimore.